All right, is this showing up here?
Yes, I can see.
Yes.
Okay. Um, okay. Hey everyone, my name is Matt. I'm an SRE on the observability team here at Uber, based in New York. And as mentioned, I'm going to be talking a little bit about how we operate etcd here. So just go over kind of some background, the environment we're working in, the different types of use cases that we're currently using etcd for, how we configure those and tune based on the use cases, and then kind of a little peek at what our next steps of some more use cases we're exploring and how we're testing out etcd. So to give you a bit of background, I'm not going to go over this too much since Chow gave an overview of this a few weeks ago, but M3 is Uber's metrics platform, and at this point, most of the core components are open source. So that includes our distributed time series database, our fault-tolerant aggregation tier, the local collector agent, and so on and so forth. And the kind of common thing that ties these together and is our mechanism for runtime configuration, service discovery, leader election, all of that is this library M3 cluster. And it's a set of interfaces for those various uses. But the common thing is that they're all at least our only implementation currently is backed by etcd, and we rely on it pretty heavily. So to give you a little bit about an idea about the environment that we're operating etcd in, so Uber operates mostly out of our own physical data centers. We also have a cloud presence with multiple cloud providers. We operate etcd in all these different environments. And for the most part, the data that we store in etcd is kind of scoped to a single zone. So for example, for service discovery for one service, we currently just need to be able to locate other instances in the same zone. Our configuration, our runtime configuration variables are scoped by zone. And so far, we haven't had to do any cross-zone leader elections or similar. So that's been the case so far, but we'll touch on that later. Our use case, we're a pretty watch heavy workload. So we have internal services, which we define as kind of the services that make up our metrics platform. And the only consumers of the data for those services is ourselves. So that means so the data that we store in etcd that we rely on for our internal services comes from a more limited set of clients, has a more predictable growth rate. So there's not we don't have any use cases for our internal clusters where other users are storing data in them. And we mostly control the growth rate, but we do have some pretty strict latency requirements because we need things like service discovery configuration propagated quickly and similar needs. But then our other use case is that we also use etcd for what we call our external clusters. The external clusters are clusters that the clients that connect to them are not just our own clients. So for example, the collector agent that I mentioned earlier, which is a local agent that runs on your hosts and you emit metrics to, and it handles the rest from there. So that runs fleet-wide. So pretty much every single host in all of Uber's physical and cloud zones are running these local collectors. And so we have much larger number of clients. They read data such as, again, runtime configuration. They read the topology for that redundant aggregation tier I was mentioning, and they inject. And again, they're pretty much just watching the the placement information for that, and the configuration variables that they consume. Again, these are, we less frequently, write new values or update values, but this is constantly watches coming from all of these agents across the fleet. The data set that we store in these external clusters is also more of a growing data set. So, for example, one use case is that users can define roll-up rules, which are consumed for their metrics, which are consumed by the aggregation tier I mentioned, and those roll-up rules are pretty analogous to Prometheus roll-up rules. So they can just remove dimensions from certain metrics and aggregate how they please. So the configuration of the clusters that we run, for the internal versus external consumers, we run separate physical clusters. So the clusters that store data for our internal services are physically isolated from the ones that external agents consume. This is since we have greater control over the number of clients, and again, we don't want some accidental bad client on the fleet being able to negatively impact our internal cluster that we use for our own services. Within the external cluster, we do sometimes logically separate into different etcd instances running on those hosts to split up data, and especially if we think it's something that data that we might be migrating to another cluster at a different point. We logically split it there, and I'll talk in a little while about that migration. And then also all of our clusters.
Yes, if we look in here,
Corrupted our database and had to manually restore, but we do run to make sure that our backup system actually works. So tuning these clusters, the external clusters. So since, again, this is data that's written to a bit more frequently, since users can write these rules, we have auto compaction enabled there. We have a larger backend limit. It's currently set to 64 gigabytes for one of the external clusters, although we're not yet anywhere near that limit. And depending on the hardware that we run on, we sometimes increase the election timeout. This is mainly we have one or two clusters that are running on spinning disks and have a larger database size. So when those go to sync to disk, sometimes can take a little bit more than a second, and we don't want to cause leader re-elections during that time. All of our fleet-wide clients have keepalives enabled. This is something that we interacted with the Chorus folks with on the ticket I mentioned there, but essentially we had some clients that would sometimes fall out of sync and not receive further watches. This was back using etcd. I think this was before 3.2.10, so I don't believe this had the latest client balancer changes in it. But either way, enabling keepalives fix that problem. And so something new that we're exploring is rolling out a global cluster. So as I mentioned earlier, we have one of the reasons that we logically separate the external clusters is that those roll-up rules that I mentioned, that is the first case we've ran into where it really is more globally scoped data. So specifically, we don't say a user changes their roll-up rules for they expect it to be applied to all zones. If we had a situation where we didn't replicate an update to one zone, or we had some error on our end, then users could see metrics coming in either under different aggregation rules or with different tags across from multiple zones, which would be confusing. So we were trying to decide what to do or how to how to best store this globally scoped data, which is separate than the mostly zonal scoped data that we had previously. We considered things like having a separate cluster in each data center and somehow replicating to it, maybe either using the etcd mirror functionality or some other system that we built, or some other higher level replication that we built ourselves. But in the end, we realized we'd still just be working around the same set of problems that could more easily be solved by having a globally distributed cluster. So this is something that, again, like I said, we're still in the testing phases for. We've been using the DB tester frameworks with pretty good results so far to kind of benchmark these different configuration of our global clusters, specifically what zones we have, what number of nodes in, and kind of comparing across those dimensions. We're also testing out having the etcd gRPC proxies in each zone that a global cluster is spread across, and then the local agents in that zone would just connect to the DC local proxies to reduce cross data center watches and just coalesce the watches from those proxies. So some initial results that we have so far, and we plan on publishing a comprehensive write-up when we're done with this testing and have rolled out and implemented this. But so this is just pretty simple. This is a 3-node cluster. This is comparing 3 different topologies of a 3-node cluster. This is all on etcd 3.3.3. So this is comparing our base, which is a 3-node cluster in one zone. Compare that with a cluster where we have two nodes in one of our physical data centers, one in another, and also comparing that with having one having one node in each of our physical data centers, and then a tiebreaker node in the cloud. Also, I just want to mention we don't actually run 3-node clusters in production. Our clusters are larger there, but this was more for just testing and demonstration purposes. So yeah, this is one of the basic tests that's in DB tester. So as we can see, not too drastically different results here, and definitely gave us confidence that this is something we could proceed with and do more large-scale testing and start to build confidence in it. So this is just, again, another one of the basic DB tester tests. But what's really interesting is that if you compare this with a cross data center Zookeeper cluster, as we can see, etcd blows it out of the water. So this definitely let us know that this is the path that we're going to be going down. So yeah, our next steps both of these past 2 diagrams have been comparing a 3-node etcd cluster and a 3-node Zookeeper cluster spread across 2 physical data centers and a cloud zone. So like I said, so far, this has given us a lot of confidence that this is the right way to proceed. Our next steps are going to be expanding our DB tester tests to include in a single test run, test out different topologies. So for example, 2 nodes in each of 2 physical data centers, and then a tiebreaker node in a cloud zone. Oh, sorry, I also want to mention our requirement here is that whatever cluster we roll out globally, our requirement is that we can tolerate an entire region failure and still maintain quorum. So that's motivated the topologies that we've been testing. But yeah, our next steps include testing different topologies with greater number of nodes across greater number of zones, and then adding in tests to DB tester for watch update latency, and then not only watch update latency against the cluster itself, but then watch update latency against the gRPC, against the zone local gRPC proxies. We plan to continue this testing, write everything up, and publish our results, and along the way contribute some more example tests to the DB tester framework. but it's been really great to work with so far, and we're excited to keep using it. So thanks for putting that out there. Yeah, in general, that's an overview of how we operate etcd at Uber. We've had a great experience with it so far, so thanks for all the hard work you folks do. And we're excited to share the results of that global cluster testing with you.
Okay, thanks, Matt. Yeah, I'm very surprised. Like, who is running D/B tester in Uber? Like, there's no really no documentation how to run it.
Yeah, so I started doing this. I just kind of looked at the code and tried out some examples. I had to make some changes because we're not running our storage on GCP, or we're not uploading our results to GCP, but that was pretty easy, and just kind of be able to iterate through different topologies quickly. But it's been fine. It's been great to work with so far. It's much better than running like in the past. We would run load tests and then take screenshots of Grafana panels during that test and then annotate them with like little buttons in preview. So this is definitely
Okay. Yeah, I have like few more questions. So do you know how Uber uses the watch client? So do you guys like multiplex watch request? Like, I mean, so you create like one like client and then just spawn like bunch of like watch request sharing one TCP connection. Do you guys do that, or like how do you guys handle what like millions of watch client?
Yeah, I think we definitely share like watch streams on etcd, because like we have millions of watches, but then the watch streams are in the number of like hundreds of thousands.
Okay.
So I think etcd is doing that already for us. I don't think we really like did anything specific for that.
Yeah, we only instantiate one client per process.
Yeah.
Okay. Yeah, actually, there's one like pending issue with the watch multiplex. Like, so yeah, we might need to fix that like in this like release cycle. But like, I will like, email you the related issue on that.
All right. Yeah, sounds good. Thanks.
Great.
And then other question. So what kind of like value you guys configure for client keep alive? Like how many seconds?
Let's see. I can tell you. Hold on, sorry. Let me.
By default, I think Kubernetes configures like something like 30 seconds, and the Reddit also configures 30 seconds.
Yeah, sorry, I'm checking now.
Yeah, because like SCD, yeah, we're trying to set it by default, and then yeah, we want to know what would be the good like default value for the client keep alive.
So our keepalives. So again, this is for the fleet-wide agents, and there's many dozens of thousands of these. So we configure a period of 30 minutes with 30-minute jitter and a timeout of 20 seconds.
Oh, 20 seconds. Okay. Sounds good. Okay. Thank you.
Sure.
The quota bytes up quite a bit. Do you have any idea what the largest data set that you've actually stored is?
Yeah, I believe currently it's only between, I think, around 1.2 gigabytes, but that's for the cluster that is kind of on a constant growth rate.
Gotcha. Yeah, I'm just kind of curious at what point we might need to go back into BoltDB and start optimizing for larger data set sizes. Cool. What other dimensions of scale do you think you might hit soon?
Yeah, one thing we were concerned with is the limit of the value of limit of the size of a value, I guess. I think the value the limit right now is like 1.5 megabytes or something. We are nowhere near that yet, but we were kind of concerned about that limit when we were like evaluating etcd, and we thought about if we eventually hit that limit, we may do some key splitting ourselves maybe, but it would be nice if etcd can just support that bigger values.
Okay, yeah, definitely let us know if you're getting close. That's interesting to know. I wouldn't have necessarily guess that would be the first dimension, but that does make sense.
Yeah. Because
Yeah,
I think the reason we may have the issue is because like LCD can't keep the full history of all the value changes. But we have one use case that's like constantly growing, and we do need history, and which is why we store all the history in the last value. So every time we just append to the history and then store it as the latest value. That's why we're kind of concerned one day it may hit that size limit.
That's why it's always growing. Got it.
Yeah.
And then how do you guys upgrade SCD? Like you just do it manually or?
Yeah, so the mechanism or our configuration management system is Puppet. So it's pretty much just we build a new package, test it out on our test cluster one node at a time, and then yeah, we just pretty much upgrade the version, Puppet, run it manually one node at a time, make sure everything's healthy, wait until we see the upgrade API message, and then we're done.
And then how do you guys like do you guys take like snapshot like periodically?
Yeah, that's the backup mechanism I was talking about. So by default, every 6 hours, all the nodes in the cluster snapshot at a minute that's splayed throughout that hour. We haven't had a need to do more frequently, but and then also if we're doing an upgrade or some other potentially destructive maintenance, we just do a backup as well. But it's pretty much etcd-cctl snapshot on a cron.
I see. And then what is the auto compaction period? Like how often do you guys do?
On our external clusters, our auto compaction period is 1 hour. And that's because those have less of a need for historical lookbacks. On our internal clusters, we currently actually do manual compactions since we have some use cases where we look pretty far back in history, but we're going to be turning that into revision-based auto compactions soon.
Okay. That's good.
Well, I have a question. Have you ever experienced a total disaster of an SCD cluster?
We haven't. We've accidentally shut down Quorum before, and we're able to recover the nodes without having to snapshot or to restore from snapshot. But yeah, we've done. We also have constant, pretty much chaos monkey tests that run and like cut off communication between nodes in the cluster and alert us if something's wrong. So even under all those regular tests, we haven't run into any real disaster scenarios yet.
Okay, curious, how many SCD clusters do you guys have?
I think we currently have 10 or 11 clusters spread throughout our physical and cloud zones.
Okay, cool, thanks.
Yeah, what was the quorum size for master clusters? Is it 3 or 5? I didn't catch that.
We run 5 node clusters in most cases, and we've accidentally shut down 3 nodes before and restored them just fine.
Gotcha. Yeah.
And
5
then, I have one more question. So how do you guys monitor SCD like in the alert SCD?
So we have our local collector can also scrape local Prometheus endpoints. So we configure our local collector agents to scrape the etcd metrics endpoint, convert that into our data format, and then emit them into M3. And then our alerting system, we have alerts for leader issues, backend size, if it's a manual compaction defrag cluster, and a few other kind of like obvious failure scenarios. And then I believe we also have client-side alerts, so kind of a more black box scenario. If clients are not getting watch updates or there's some error there, then we'll also get alerts from our own agents.
Also, when do you alert from server side?
Sorry, can you repeat that?
Also, what is one of the alert like rules? Like, what is the scenario you alert? Like leader goes down.
Like one example is if we see a sudden drop of number of watches on the LCD cluster, let's say if it suddenly dropped like 50% or something, we alert on that. Also, we alert if yeah, if there's no leader for sustain more than X minutes, we also alert on that. Yeah, we got quite a few alerts. Forgot anything else.
Thank you.
Are you guys still using many other consensus systems at Uber? Do you guys still use Zookeeper in other places or Console or anything?
Yeah, we have teams using Zookeeper pretty heavily. It definitely underpins a lot of Uber's infra. We chose etcd for this for our open source needs just because we liked it more, and yeah, that's pretty much it. But now we're trying to evangelize the good word of etcd internally and see if we can convert more use cases. And personally, I think those like DB tester graphs are pretty telling, but you know, internal stuff, so we'll see.
Yeah, I love that graph. I'm going to show that to some people.
So a couple of questions actually. One is that do you use etcd for service discovery?
Yeah, so that that library I was talking about, M3 cluster, we use it for we have the notion of a placement which is comprised of a set of shards and nodes owning that shards, or nodes owning those shards at some number replica factor. So we do, that's kind of our mechanism for service discovery, is just watching those placements. Those are all stored as protobuf serialized messages in etcd, and then the clients deserialize and update their, update the placement according to their own use case.
Is this Uber-wide service discovery, or is it just for certain parts of Uber?
It's currently just for our metrics platform. Like I said, we're going to see if there are other teams that want to onboard onto the tooling that we've created. And we're also constrained by the fact that like all of our most of our metrics platform is now open source. So we just wanted to build all these open source libraries and then leverage them ourselves so far.
Got it. And then one last question maybe. Is like you mentioned comparison of etcd with Zookeeper, console, etc. You said that one of the advantages, of course, is open source. But is there any other? What was your sort of overall decision about pros and cons of these different systems?
Sure. One of the things we really liked about well, we knew going into this that our metrics platform so far is going to be written in Go. One of the things we really liked about etcd going into it was the native Go client support. The Zookeeper Go client is unofficial, has some issues with it, and at least with etcd, we knew that the Go support was pretty much first class. And additionally, operationally, it seemed a little bit easier. And the preliminary load tests, we first started looking at it when V3 was already out. And even back then, it was pretty telling that it was the right direction.
Yeah, also performance-wise, I think etcd is like giving much better compared when we were like evaluating console. So.
Okay, thank you.
Okay, I have a question. I was curious about what some most common operating issue that you guys have encountered for etcd when you guys are operating etcd.
I don't know, a bunch of the issues we ran into, some of them were actually like hardware related. So for example, we had like on some of our hosts, the IRQ affinity of our like network card queues was not so great and was all hitting one core, and we thought that it was an etcd issue. We saw pretty regular leader timeouts. Turned out that was a hardware issue. Operationally, that bug I mentioned in that one slide where that we had to roll out the keepalives for, that was, I think, the main operational issue we've ran into so far. And I think in the upgrade from V2 or 3.2 to 3.3, I think the YAML or the type for the YAML definition of auto compaction retention changed from an integer to a string, and our like configs were templating it out as a integer. So we had some like cluster reload issues there. But other than that, we're pretty pleased with how it operates at steady state. So,
Yeah,
no
cool.
complaint.
Sounds good. Sounds good.
Remember the case where one box had like disk issues and then we lost leadership for a while?
Oh, yeah, there actually was one case recently where one of our hosts had a XFS disk lockup, and it couldn't process any etcd requests since it couldn't make any progress on disk. But it was still responding. The connection was still active since the host was still up and the network was fine. So there was kind of I think it took a while for the leader type failover to kick in, and the cluster got a little backed up for a minute. So actually that was one thing we ran into recently. I forgot about that.
Okay, good to know. Good to know.
So in general, have you found that the HCD cluster is very sensitive to the disk performance, as people have generally said in the documentation?
Yeah, I wouldn't say it's more sensitive than we'd expect. I mean, like I said, some of our clusters run on spinning disk, and we just bumped the leader timeout and some other timeouts, and that was enough. For our clusters that run on solid state, that's I don't think we've ran into too many disk sensitivity issues. Yeah, I would say nothing beyond what we would expect.
At Braintree, we had that problem. Sorry for jumping in, and we actually run our etcd cluster all on RAM disk now, which has evened things out a lot, especially in virtualized environments where the disk performance isn't super consistent.
Yeah. Our main clusters that are under the most load are all on-prem, so I think we've kind of been lucky there.
Okay, thanks.
Yeah, any other questions? Okay, thanks, Matt and Chao.
Sure thing. Thanks for having us.
Okay. Yeah, any other just questions on etcd? No.
This isn't an etcd specific question exactly, but at Braintree, we're interested in running one of these presentations about our experiences so far. Should we do anything other than just throw our name onto the Google Doc, or is there a procedure or anything?
Yeah, sure. You can email me and then just add your name on the Google Docs. That'd be great.
Perfect. Thanks.
Okay.
And I think we are also interested in possibly contributing some more performance work in kind of in the same vein as the lease improvements that we contributed.
Yeah, I saw the PR. Yeah, I haven't looked at it yet. Sorry. Yeah, but we can discuss more in the email or later.
No worries. Thank you.
Yeah, we definitely want to do that. Okay. Yeah. Thanks, everybody.
Thanks.
Thank you.
Thank you. Bye.